This is 3.3 rules of differentiation. Yeah, so you guys know this definition, right? So I just showed it to you last lecture. So that slope or first derivative, right, f prime of x, and we have this limit with h approaching 0. And then we have this f of x plus h minus f of x. Right, and I hope you understand and you remember what this is coming from. But normally we wouldn't calculate the derivative using this definition, right? It's just a little bit too, too labor intensive. Anyway, so I'll give you a couple rules, couple ways that we can calculate derivative much easier. Let's start with the derivative of just a constant. So let's say 7. Okay, so the question is, what is the slope? So if you have, it's just a horizontal line, right? We could graph it quickly here, right? So here you go, y equals 7 or f of x equals 7, and the question is, what is the slope? And the slope simply is 0, right? So m equals, right? So we have the derivative, and it's 0. So our first rule, our first conclusion is that simply if you take a derivative of a constant, so let's write it this way, right? So I want you to get familiar with all of those notations. So dx of some kind of constant. Let me actually put it. No, that was all right. Let's just put c, constant. Right, so any constant, derivative of any constant is 0, right? So this could be, right, so derivative, let me give you a couple examples. Right, so if I have pi, derivative of pi is 0. And derivative of number e, 0, etc. Okay, so the second rule, maybe before I show you the second rule, maybe you can guess what that is. So let's say I'm trying to figure out the derivative of, it's called problem A, y equals x cubed. I don't know, maybe you've seen it somewhere in your pre-calculus class. So we're trying to figure out what y prime is. And so that y prime will be 3x squared. Okay, so then B, problem B. So y is 2x squared. Right, so think, what could that, right? You can pause the video if you want. What could y prime be, right? What could be the derivative of 2x squared? Well, it's 4x. Okay, so now let's do a couple more. So C, we have y equals x to the 5th. Right, so again, what is the derivative of that? 5x to the 4th. And the last one, that should not be equal sign. So derivative, let me write it a different way. Let's do f of x equals x. Right, so I hope you know what derivative is, right? That because derivative is slope, right? The slope in this case, it's just a number, and it's 1. Okay, so I hope you figure out what the rule is. You figure out what's happening. Right? I can tell you, right? So that 3, right, is going to go to the front. right? You see that 3 here. And then this exponent, right, was 3, so I'm going to subtract 1 from that exponent. Right, so that's what happened everywhere. Right, so that 5 went to the front, and then I subtracted 1 from that exponent, etc., etc. Right, so here 2 went to the front, became 4, and I subtracted the exponent, right, became 1. Okay, and the same here. So 1 to the front, and then we could think about it as 0, right? X to the 0 power is 1, so just 1. Okay, so let me write that rule. I think we had it in blue. So it's called the power rule. And it's the most useful and most basic way of calculating those derivatives. And it's, yeah, applicable to any functions and not necessarily polynomials, but whenever you have x to some power n, right, that n can be, doesn't have to be an integer, right? Doesn't have to be a positive integer. This could be a fraction, but basically it has to be a real number. Anyway, so f prime of x equals, right? So you see that n comes to the front, and then it's x to n minus 1. Okay, so yeah, as I was saying, right? So this went to the front, and then I subtracted 1, right? And we see it here. Okay, so let's do a couple maybe slightly more complicated examples. So let's call it example 1. So we have let's do yeah, so we had those, right? You guys have seen those, like x to the 4th, right? X to the 3rd. It's, I hope, I don't know, now I'm thinking maybe we should do a couple more. So let's do something like this. So let's do 3 x to the 4th, right? So derivative of 3x to the 4th. Okay, so just like, man, we were doing before, that 4 is going to go to the front and will be multiplied by 3. Okay, so we have 3 times 4. And then here we have x. I'm just gonna do it once, right? Just gonna show you all those steps. Okay. So yeah, I have that 4 minus 1. So we'll have 12. And here I have x to the 3rd. Right? So that's the derivative of 3x to the 4th. Okay, so let's do a couple more. So b, that's the derivative of x to the 2/3. Okay, so first step, right, this 2/3 goes to the front. Right, so we'll have 2/3. And now I'm going to subtract 1 from it, right? So 2/3 minus 1 is negative 1/3. So negative 1/3. And we'll have 2/3. And then x. And right, you guys, I hope you remember from pre-calculus that negative in the exponent makes this whole expression to go into the denominator. Right, so I'm going to write 1 on the top, and now this whole x to 1/3 is in the denominator, right? So this 1/3 is an exponent. Let me write it in a different way. Right? And let's write it this way. So 1/3, and finally we'll have maybe, yeah, let's write it this form. So 2 on the top, and here we have 3, and it's a cubic root of x. Right, so 1/3, the exponent of 1/3, right, is the same as cubic root of that variable. Okay, so that's the final answer. All right, so yeah, let's do a couple more. Let's do something like this. So we have d dx. Let's write it some other way, right? So let's do y equals 1 over x squared. Okay, so we need to figure out what y prime is. And yeah, before I get to this, let me rewrite this 1 over x squared, right? So 1 over x squared is the same as x squared, or x to negative second power. Okay, so I'll have, so now I'm gonna write here, right? Negative 2, so I'm taking this negative to the front, negative 2 to the front. And then we have x to negative 2 minus 1, right? I'm subtracting 1. Okay, so we have negative 2. And then I have x to negative third. And then just like in the previous example, that negative in the exponent is going to take that variable, right? So guys, I hope you understand, right? So now the way it is written now, that negative 3 applies only to x. It doesn't apply to 2 or negative. If I wanted to communicate, if I wanted to say that negative 3 applies to, say, 2 and x, I would do it like this. If I wanted to if I want that negative 3 to apply to all of those, right, I would do it like this. But for now, the way it's written, it's just like that. Okay? So now that negative 2 stays on the top, and then x to the third, right? So it's no longer negative third, because that negative got spent, right? Got used for making this negative, this x to the third, move to the bottom. Okay, so we have that. Yeah, so I'll give you a couple of problems for practice. And yeah, and then we'll do more examples. That's a practice. Yeah, so calculate derivatives. I'm not going to write it. So this one is fifth root. This doesn't look like 5. Let me try again. 5, that's better, of x. Alright, so when you're doing this problem, rewrite that radical, the fifth root of x as x to 1/5, right? And then it's easier to subtract 1, etc. Okay, so number 2, f of x. And so this one is 1 over x to the 5th. Number 3. Okay, so this one looks a little strange. This one is s of t to the t to the third plus 5x squared. It can't be x squared. I mean, it could be, right? But that's not the point here. So it's t squared and minus 3t. Right, so here the variable is different, right? It's just t, but the process is the same. Right? So I know I haven't told you that, but when you have a polynomial, you just simply take a derivative of all those terms separately, right? So derivative of this, derivative of that, derivative of this, and derivative of that, right, separately. It's not. Okay, so kind of by properties of derivatives that you guys haven't seen yet. I'm struggling here. Anyway, right, so these are all primes, so those mean derivatives of those separate terms. Okay, and the last one. So I'll go over that last one, right, because there's some algebra that you may not remember involved. Square root of x over x. Okay, so let me give you the answers. So the first one is 1 over 5, and then x to 4/5. This is 5. Oh, let me fix that. Let's do it this way. So 5. Okay, it looks good enough. But now, of course. All right, the second one, what I have is, so derivative, that does not equal, right? It's just, so the second one is -5 on the top, and the bottom is x to the 6th. Okay, then we have the third one. Third one, I have 3x squared plus 10t minus 3. Okay, so that's the answer of that one. And yeah, so I'm not gonna go over this whole thing. Number 4, I just want to show you, right? So we have that square root of x over x, so we can rewrite it as x to 1 over 2 over x. We could write 1. Okay, so we have x to 1 over 2 minus 1, right? When we divide, we subtract the exponents. So this is x to -1. It's not -1. It's -1/2. Okay, so -1/2. So now, right, you take a derivative of this, and what you should get is -1, and then we have 2x to 3 over 2. Okay. Yeah, so these are the a couple problems for you to do. Okay. What else I want to show you? All right, so let's do one example just to kind of remind you that derivative in a sense is slope. Okay, so example 2. Okay, so let's so given, let me write it this way. Given f of x, right, our old friend f of x equals x squared. Find slopes of tangent lines lines tangent to the graph at x equals -1, then let's do 0, and then 2. Okay, so I hope you remember, right, what's going on. But basically, right, we have this parabola. Y equals x squared. Okay, so something like this. And we have those, right, couple points. So the first one was -1, so we need to locate -1, right? So -1 is here. Then we have a point on that parabola. So what we need to do is calculate slope of the line tangent the graph at that point. Let me try to graph it. Okay, yeah, so that's our task number 1. And then at 0, hope you guys can see what that slope will be. Okay, and then the last point was 2. So let's make it yellow. So 2 will be here, and the tangent line, something like this. Okay, so let's try to figure it out. So first step would be to calculate the derivative, right? So if f of x or y, right? So y equals x squared. So y prime or f prime of x would be 2x. Right? And then we simply plug in those numbers. So f prime of -1, and we plug it in. So 2 times -1, -2. Then the second one was 0. So f prime, now we could make it somehow color coded, right? So that's the red one. Now we'll have the green one. So f prime of 0, right? So we'll just plug in 0. So 2 times 0, 0. Right? So obviously it's a horizontal line. Right? I'm talking about the green one. Slope is 0. Okay. So m of this one was -2. Slope of the green one was 0. And now we have the last one. So f of 2. Plug it in. So we get 2 times 2. So that's 4. Okay, so the slope of this one, m equals 4. Yeah, I just wanted to remind you, right, that what we're essentially doing, we're calculating, right? We found the formula for slope, and now having that formula, we can calculate slopes at every point. All right, so next rule, I think it's rule number 3. It's called constant multiple rule. And this one is pretty intuitive, so we're not going to spend a lot of time on it. So let's say I'm calculating, how should I write it? Maybe like this. Derivative. Right, so we have some kind of function f of c of x. Okay, so that's simply, we can take that c and put it to the front. Right, so in a sense factor it out, right? It's not really factoring. So now it's going to be c. How should we write it? We could write it, let's write it like this. d dx of f of x. Or maybe like this would be more legible. F prime of x. Okay. All right, so let's do a couple examples to illustrate this. Okay, couple examples. I'm just gonna do example 1. Yeah, so find derivative of y equals 2 over x. So 2 over x. Okay, so let's take the d over dx notation and let's use it. So 2, and then I'm going to write x to the negative 1 power. It's negative. Okay, let me fix it this way. Negative 1 power. And based on the rule, on that rule above, right, we can just take that 2 and put it in the front. So 2, and then I have d dx of simply x to negative 1. Okay, so that negative 1 goes to the front. So we have I'm getting better at this. So we have what? We have 2. And then I have that negative 1 that goes to the front. And then we have x. Negative 1 minus 1. Okay, so the answer is negative 2. And then, right, I have this, that expression. So that's going to be x to negative 2, so x squared in the denominator, right? So that's the final answer. Okay, so that's the first example. Let's do another one. So example 2. And this one is similar. So again, right, we're calculating the derivative f of t. And the function looks like this, 5 times square root of t. So maybe this time I'll use the f prime notation, right? Just kind of to expose you to different types of notation. So let me do it this way. So f prime of t. And then I have this. Well, the problem is that now I can't really show you how that rule works. But anyway, right? You guys see that 5, right, is basically going to go in front of the. I don't want to put it there because it's gonna look kind of weird, but in a sense we actually could, right? So let me do it. How should I write it? Maybe I write it like this. So like this. So 5 t, and then we have that. And I'm showing that we're taking the derivative of this, and now I'm going to take that 5 and put it in the front. Okay, so like this. And now I have t to 1 over 2 power, right? That's what square root is. I'm taking derivative of that. The prime is kind of too long. Okay, now it's too short. Now it looks like y. Okay, we try it last time. Okay. Okay, so let's take the derivative of t to 1 over 2. Okay, so I have 5. Right, 5 in the front. And then that's going to be times. So I have, let's do it like this. So half. Right, that exponent goes to the front. And now it's going to be t half minus 1. Okay, so we have 5 over 2, and then that's going to be t to negative half. So the final answer will be 5 on the top, and then 2 here, and it's going to be square root of t. Okay, yeah, so that's that. And the last problem, let's do example 3. I mean, it's not the last problem. And that's going to be okay, so y equals, somehow it got darker, I'm not sure why. Okay, so y equals, I have 2 over 3x, and that's to the negative second power. Okay, so before we take a derivative, let's simplify it. Okay, so that will be that negative 2 in the denominator, right? This one applies to both, right? To 3 and to x. And also, right, if I have negative exponent in the denominator, that's going to make this whole expression go to the top. Right? Just like if I have a negative exponent in the numerator, that makes the whole expression go to the bottom. Anyway, so I have, right, so we have 2, and then we have 3x to the second power, right? So that negative got spent. Now, right, we're doing exponent first, so we have 2 times, so in a sense, right, I'm distributing that exponent. That's not really correct wording, because that's not really process of distributing, but essentially that's what's happening. So that would be 9 and then x squared. All right, so now finally it will be 18 x squared. So y prime will be 18x squared. We'll take a derivative of that. So 2 goes, right? 18 is just a constant, so it doesn't really go anywhere. But that 2 goes to the front, so we'll have 36x. And I subtracted 1 from that 2. Okay, so that's the final answer. Okay, so next rule is something that we've seen before, right? So that was, I gave you a problem with, this one. Talking about this problem. Right, and I told you that you can basically take a derivative of each of those terms separately, right? And that's that next rule. So I'm going to introduce it officially. So this is rule number 4. Right, and derivative, it's a derivative of a sum or difference. Is there more space now? Okay, so if we're taking a derivative of a sum of some two functions, d dx, f of x, plus or minus g of x. Okay, so we simply, I don't have space here, but I'm going to write, so we take a derivative of f of x, right, so f of x, and then plus derivative of g of x. Okay, so yeah, it can be plus or minus. So it's a pretty intuitive, pretty simple rule. Let me give you an example to illustrate it. Maybe. So example, I have 5. I hope it's correct. And it goes like this. So we need to calculate derivative of 3x to the 5th minus 14 pi. Alright, so we take derivative of those two terms separately. So derivative of the first term, right? 5 goes to the front, minus 1. So it's going to be 15 x to the 4th. And now 14 pi is just constant, so derivative of constant is 0. So the final answer is 15 x to the 4th. Okay. Yeah, so there's another rule. It's called chain rule. And I think that's part of the next lecture, but I just want to show you one thing, right? That I see students just maybe struggle with a little bit. So when I'm taking a derivative of two functions that are multiplied, so f of x, right, times g of x, okay, so that does not equal to derivative of f of x, right? So it's not that simple. So d dx of f of x times derivative of g of x. So we simply cannot do what we did with the addition, right? So I took right, derivative of the first one, derivative of the second one, we subtracted them, and we got the answer. So when you're multiplying, it doesn't work this way, right? It does not equal to derivative of the first one times derivative of the second one. It's slightly more complicated, not much more complicated, but yeah, a little bit. Okay, so let's look at the last thing, I think. Or maybe not. Let's look at trigonometric functions. Okay, so derivative of trigonometric functions. Okay, so yeah, I'm not going to prove anything here. But derivative of sine of x is simply cosine of x. Now derivative of cosine of x, that is negative sine of x. Okay, so yeah, just remember that. The negative. Right, important. Okay, so I don't know, let's do a couple examples. The first one maybe, so example 1. Let's do find the slope. Slope of a line tangent to y equals sine of x at 0, at origin. Okay, so yeah, so what we need to do is, right, so slope equals, we have derivative of sine, right? We're trying to figure out what that what this slope, maybe I should have made a drawing first of the situation. Yeah, let me do it. Okay, so what's going on? So we have a graph of sine. Okay, so maybe this is pi over 2. This is pi. Negative pi over 2. Negative pi. And I hope you remember. And then, right, it oscillates between 1 and negative 1. So this is 1. This is negative 1. And yeah, the graph oscillates between negative 1 and 1 for pi over 2 is 1, for pi is 0, for negative pi over 2 is negative 1, negative pi is 0. Right, so it goes something like this. Okay, so we have the graph of somehow it looks like, well, whatever, I'm not going to redraw it. It shouldn't go below negative 1. And here, right, maybe it should go a little bit higher. Anyway, yeah, so the question is, right, we have that origin, and we have the tangent line, and it goes, here's the origin, here's the tangent line, and we're trying to figure out the slope of that line. Right, so recall that, right, slope is basically the first derivative is going to give you formula for slope. So let's figure it out. So d over dx, right, so that's going to be m of sine of x. Right, derivative of sine of x is cosine x. So now, right, we need to figure out what that value of cosine for 0 is. So I'm already writing the answer. So x is 0, so we do cosine of 0, and that is 1. Okay, so slope is 1. Yeah, so slope of that line at that particular point, right, at 0, 0 is 1. Okay, couple other examples. So let's do example 6. I say 6 and I write 1. Yeah, 6. And it looks like this, right? So we need to figure out derivative of 3 sine x plus pi. Right, so this is a sum, so calculating the derivative is pretty simple. 3, right, so we basically calculate derivative of those two terms separately, right? So we have derivative of the first one is just 3 cosine x, and pi is a constant, so it's 0. So that is the answer. All right, example 7. All right, so we have derivative, and then 5x squared plus 1/3 cosine x. Okay, so again, right, it's just a sum, so we can calculate it pretty simply. So we have derivative of 5x squared is just 10x. And derivative of cosine is negative sine. So this is going to be negative 1/3 sine x. Okay, so the final answer will be 10x minus 1/3 sine x.